Hello GCC Chem 130 students. We're going to finish chapter 4 right now. So we just finished looking at the 3 subatomic particles. Next is atomic notation. So atomic notation is when you write the element symbol, and in the upper left corner you put the mass number, and in the lower left corner you put the atomic number. So what are these numbers? The mass number is how much the atom masses or weighs. Masses is the better word. And so when we think about an atom, it's made of protons, neutrons, and electrons, but we just learned that electrons' mass is negligible, basically 0. So the mass is going to be the protons plus the neutrons. So we're going to add those together. That is our mass number. It's going to be a whole number, right? Because you can't have part of a proton or a neutron. So it's a whole number, and it's the protons plus the neutrons. That's the upper number in the left corner. Now the atomic number is just the number of protons. That's it, just the number of protons. Okay, and that's the lower left number. And then the element symbol is like O for oxygen, C for carbon. And so that's called atomic notation. So the atomic number again is the number of protons. Every atom of an element has the same number of protons. If it's a carbon atom, it has 6 protons. If it has 6 protons, it's a carbon atom. If it's an atom, the protons and the electrons have to be equal. This is because an atom is neutral. So if we have 6 protons, which are positively charged, we have to have 6 electrons that are negatively charged to balance out and make the charge neutral, add up to 0. So 6 pluses, 6 minuses, cancel out, neutral atom. The number of protons defines an element. So let's look at our periodic table. Let's look at carbon. Carbon has a little number 6 there. That is the proton number, that is the atomic number. Okay, hydrogen has a little 1 there. That's the proton number. That's the atomic number. Hydrogen is 1, carbon is 6, oxygen is 8, and so forth. That is the number of protons. So that's given to you on the periodic table. All you have to do is look. So, for example, carbon atoms have 6 protons always. If there's 6 protons, it is a carbon atom. Mass number. The mass of an atom is very, very small. Again, we make up our own unit, atomic mass unit, AMU. Protons and neutrons are 1. Proton, neutron. They weigh 1. You put them on the scale, they weigh 1. Electron, teeny, teeny, tiny. You put it on the scale, doesn't really register. 0, it's negligible. It's almost 0. It's 1,836 times smaller than a proton or a neutron. So it's basically 0. Mass number is the top number. So again, it's the protons plus the neutrons, not the electrons. Just the protons plus the neutrons. So, if the mass number is the protons and the neutrons together, and the atomic number is the protons, how can you calculate the number of neutrons? If you said subtract, you're right. All you have to do is take your mass number minus the proton number. That'll give you the neutrons. So you subtract. The top number minus the bottom number gives you the neutrons. Here's an example. Let's write the atomic notation for potassium 40. You should know what potassium is. Potassium is what symbol? It's a K. Let's find K. There it is. So what's the proton number? Proton number for K is 19. Okay? And I gave you potassium 40. That is not a negative sign, it's a dash. Potassium dash 40. 40 is the mass number. That is something I will give to you. You have to get the protons from the periodic table. So potassium is K. K is number 19. That's the proton number. The 40 that I give you is the mass number. That's the protons plus the neutrons. So write your atomic notation now. Alright, so hopefully you wrote this. A K with a 40 on top, that's the mass number, and a 19 on the bottom, that's the proton number. So 40 over 19K. Now, how many neutrons are there? Remember to subtract. Yes, if you got 21. Good job. There are 21 neutrons in an atom of potassium-40. All right, let's try another one. Let's write the atomic notation for bromine-81. Bromine-81. What does the 81 mean? Yes, it's the mass. What's the symbol for Br? Oh, crap. What's the symbol for bromine? I just said it, Br. So let's find Br in our table. Oops on me. There we go. There's bromine. It's number 35. That 35 is what? Number of protons. Yes, number of protons. So what's the atomic notation? Write it now. So you're correct if you put 81 over 35 Br. How many neutrons are there in an atom of bromine 81? Subtract. And yes, if you got 46. There are 46 neutrons in an atom of bromine 81. All right, so hopefully we're doing good so far. Let's keep going. Isotopes. Isotopes of an element have the same atomic number of protons, but they have a different mass number. So if the protons are the same, but the mass is different, then what's really different is the number of neutrons. Okay, so again, protons define an element. 6 protons is carbon, carbon is 6 protons. But neutrons can be whatever number we have. Example, carbon comes in carbon 12, carbon 13, and carbon 14. It also comes in carbon 11. So those are called isotopes of carbon. The 12, the 13, and the 14 is the mass number. What's the proton number for carbon? 6, yes. Remember, carbon is number 6. That is always and forever 6. Carbon is 6. 6 protons. So carbon 12, carbon 13, and carbon 14 have how many protons? 6. Okay, so they all have 6. How many neutrons are in carbon 12? Remember to subtract. There's 6, yeah. What about carbon 13? 7, yeah. And carbon 14? 8, yeah. So we're just taking the 12 minus 6 is 6. 13 minus 6 is 7, and then 14 minus 6 is 8. So the neutrons were 6, 7, and 8 for those atoms. See, the neutrons are different. That's what makes them isotopes. But protons was the same element, 6 protons. Neutrons were different. That makes them isotopes. So now I want you to fill in the table with these isotopes. I have oxygen 16, oxygen 17, oxygen 18. You need to pause and fill in this table. Seriously, pause. Pause now. Okay, we're back. So, oxygen 16, the mass number is 16, because that's what the number is after the element with the dash. That's the mass. Oxygen 17, mass is 17. Oxygen 18, the mass is 18. Great. Number of protons. Oxygen. You're correct if you said 8. 8 protons for oxygen 16. What about oxygen 17? Still 8, because it's still oxygen, so it's still an 8. It didn't change. Still an 8. What about oxygen 18? Yeah, still an 8. So 8 protons for all of them. Now what about neutrons? Oxygen 16 has 8 neutrons. What about oxygen 17? 9 neutrons. And oxygen 18? 10 neutrons. Very good. What about electrons? Do you remember electrons are equal to what? Protons in an atom that's neutral. So the pluses and the minuses have to be equal to cancel out. So the electrons are all 8 as well. Let's look at the answers. There we go. Protons and electrons are all 8. Neutrons are 8, 9, 10. Mass is 16, 17, 18. I hope you filled that in right. We love this table. You will see tables like this on quizzes and exams and homework. Okay, so you need to be able to fill in a table just like this. All right, moving on. So you may have wondered, what's the other number with the decimal places in the table? You've probably been wanting to ask that. So that other number is not a whole number. So it cannot be the mass of one atom. It's not the mass of an atom. So let's look at carbon. Now remember, carbon comes in 11s and 12s and 13s and 14s. So what do you think the 12.011 is? It's the average of all the isotopes of carbon in the world. Okay, so it's not the mass of one atom. The mass of a carbon atom is 11 or 12 or 13 or 14. But if you average those all together, we get 12.011. Okay, so the number that's the mass in the table is the weighted average of all the isotopes for that element in the world. That's why it's not a whole number, because it's an average. So again, using carbon as my example, carbon 11, there's just a little bit of that. Carbon 12 is 98.89% of carbon, so that's the majority isotope. Most carbon comes in 12s. Carbon 13 is 1.11% of carbon. Carbon 14, again, is just a trace minor amounts. Carbon 11 and 14 are both radioactive. We have the carbon in our body, and so some of it's radioactive. It's okay. The mass reported for carbon in the table, 12.01 AMUs, is closer to carbon 12. Carbon 12 is the most abundant isotope. We're going to use the word abundant, meaning there's a lot more carbon 12 than any of the other carbons. Okay, most carbon is the carbon 12. So look at the periodic table, and I want you to determine the most abundant isotope, means which one we have the most of, abundant. Lithium, what's lithium symbol? Li, so find Li. There it is. Okay, so is lithium 6 or 7 the most abundant isotope, given that lithium's mass is 6.94? 6.94. It's closer to 7, yes. So lithium 7 is predicted to be the abundant isotope because the average is closest to it. Now look at chlorine. Chlorine 35 or chlorine 37. What is the symbol for chlorine? Cl. Let's find Cl. Here it is. Chlorine's mass for all the isotopes in the world is 35.45. 35.45. That is closer to chlorine 35. So yes, chlorine 35 is predicted to be the abundant isotope. All right, moving on. Some isotopes are radioactive. So some elements are radioactive and unstable. Radioactive means the atoms are unstable because the nucleus emits ionizing radiation such as alpha particles, beta particles, or gamma rays. And this just happens naturally. Okay, you can't stop it. This is distinguished on the periodic table with parentheses around the mass number. Look at some of the very bottom ones. They are, a lot of them, in parentheses. Okay, so they're in parentheses. Parentheses means that the only isotope that we know of is radioactive, so there's not any stable ones. For example, element 96, curium, Cm, it's in parentheses 247, that's its mass, that's its protons plus neutrons, and because it's in parentheses, it's radioactive. Chemical formulas. Chemical formulas tell us the type and number of atoms in the molecule. Does not tell us how they're bonded together, however. The number of atoms is indicated by a subscript after the symbol. If it's only one atom, we don't actually write a 1. So H2O means 2 hydrogens, and then there's nothing after the oxygen, which means it's a 1 oxygen. So H2O has 3 atoms total. 2 H's plus 1 O is 3 atoms. But water's not bonded HHO. It's actually bonded HOH. And we'll learn more about bonding when we talk about Lewis dot structures. Next one, C3H6O3 means we have 3 carbon atoms, 6 hydrogen atoms, and 3 oxygen atoms. Makes 12 atoms total in that molecule. Capiche, right? Okay, and then the last one, in parentheses, NH4, then a 2, CO3. What does that mean? How many atoms are in that molecule? Well, it means there's 2 NH4s. So there's one NH4, there's another NH4, then there's the CO3. So we've got 2 nitrogens. We've got 2 times 4 is 8 hydrogens, 1 carbon, 3 oxygens, makes 14 atoms total, right? 14 atoms? Okay, good job. So, how many atoms are in each of these formulas, chemical formulas? H3PO4, Ca in parentheses OH2, Al2 in parentheses SO4 with a 3. So pause and figure this out. Pause. And we're back. So how many atoms are in each of these? Well, H3PO4 is 3 plus 1 plus 4 is 8. Don't forget there's 1 phosphorus. Don't just add up 3 plus 4 is 7. It's 3 plus 1 plus 4 is 8. Then the Ca in parentheses OH2 is 5 atoms. It's 1 calcium, 2 oxygens, 2 hydrogens makes 5. 5 atoms. And then the last one, there are 2 aluminums, there are 3 sulfurs, and then there's 12 oxygens, makes 17 atoms. Okay, 17 atoms in that last one. All right, last of all is the law of definite composition. Honestly, this isn't a real important law for us, but I need to tell you what it is. Compounds contain the same elements in the same proportion by mass. So, for example, water has 2 hydrogens and 1 oxygen always, whether it came from a cup of water in Phoenix, or it's part of the Indian Ocean, or it's part of a melting glacier. H2O is H2O is H2O. And hydrogens are little, and so it ends up being 11.2% hydrogen by mass and 88.8% oxygen by mass, and that's always going to be the same because water is water is water, H2O. And we're done with Chapter 4. Thank you so much. I hope you have a good day. See you next time.